Okay, so first let me present myself. So I'm Cyprien Rousseau. I'm Technical Manager for the European region, and I will be the presenter of today's introduction to MIDAS GTS for Geotechnical Engineers. And this is a webinar special for Romanian engineers. So I hope you will enjoy today's session, and you can left some comments, some question into the question section during the webinar. We will answer all that at the end. So during today's webinar, I will talk about all these points. So it will be first an overview about the software, about MIDAS GTS. Then we'll talk about the modeling and how it works. Finally, I will talk about the analysis capabilities, and I will show you some post-processing and some project application as well. Now, let's begin with the product overview. So MIDAS GTS is composed of a pre-post engine by MIDAS IT and a powerful solver made by TNO Dyna, and it can analyze a lot of geotechnical problems. So here you have a few examples, but I will give you a bit more detail right after. So first of all, let's talk about the application areas of MIDAS GTS. So MIDAS GTS applies to the deep foundation and the soil structure interaction of all kind of geostructures. You can model also the deep excavation and the temporary structures, the unconventional tunnel intersection, and the shield TBM excavation sequence. You have also all kind of dynamic analysis and blasting analysis, underground structures like the subway, disposal facilities, groundwater flow can be analyzed, and slope stability embankments. So I'm just doing a wide overview, and I will give you a bit more detail about each of these functionalities right after. So why should you use MIDAS GTS? Because it is a full integrated software. So you have a powerful pre and post processor which help you to do the modeling and the meshing. You have some solvers which are very fast to help you to analyze any kind of geotechnical problem. Very good user-friendly interface. And of course you have MIDAS technical support to help you at any stage of your analysis. So MIDAS GTS will be time efficient for you. It will help you to generate quality reports and also increase a lot the productivity of your company. Now, MIDAS GTS is very powerful to model any type of 3D complex geometry. So it can be, like you see in the screen, plant structure, underground subway stations, piled raft foundation for high-rise building, or excavation using all kind of elements. You can also investigate different type of pile diameters, considering several properties. So this is a model of a high-rise building pile foundation. You have different type of superpile elements that can be used, and all that considering the soil structure interaction effects. GTS is also very powerful to analyze the soil structure interaction between the pile structures and the soil. So we have special elements which are here to model the nonlinear behavior between the pile and the soil and capture the friction of this behavior. And all that is modeled into 3D, of course. Now, unconventional tunnel intersection can be modeled as well. So you have all the tools needed to model very quickly this kind of complex system. You can use also special wizards to do that, and any kind of complex project can be analyzed. Now, Shield TBM is also uh, a big problem for some companies. So in GTS, it's very powerful to do Shield TBM analysis because you can use the construction stage analysis and you can investigate the stage-by-stage excavation and the behavior of the soil. Now, for complex 3D excavation, all the tools are also provided, like the 3D excavation by sequence. So you can view the dewatering process stage by stage, and this includes all the structural behavior, including the anchors, the diaphragms, walls, that can be generated automatically. Now GTS can help you to model the groundwater flow as well. So we have a module to model the hydraulic boundary condition and consider all the groundwater flow in the soil. So it's useful for dam analysis, or you have also stress seepage semi-coupled analysis. I will talk about that in a few moments. And you can perform dynamic analysis. So dynamic, there's two main purposes. One is to analyze the seismic response of the soil. The other one is the blasting. So these two kind of modelization can be considered in GTS and much more. And GTS supports 64-byte solver and multi-core parallel systems. Now, another very powerful thing about MIDAS products is that we provide a lot of online training and on-site training. We do some events and conferences all over the world. And if you go on MIDAS website, you will be able to download freely the trainings, the tutorials, all that is provided. And I will talk also about the events that we'll do very soon in Romania. So in Bucharest, we will organize an event on the 5th of November. So if you want to register to this special event, you can go on www.midasit.ro, and here you will see all the details about this event. So I hope you will come. A lot of engineers will come to this event, so it will be a very good occasion to meet all the engineers and talk about the modelization and the softwares and a lot of other engineering topics. Now, MIDAS provides technical support all over the world. So in a lot of countries we have partners. We have 5 branches actually in India, in the USA, in Japan, in the United Kingdom, and in China also. We have some branches and more than 24 partners in all other countries. So to resume the first paragraph, MIDAS GTS provides essential modeling tools you need to model any 3D complex structure, various types of interface elements, 3D excavation and tools. GTS consider the following diameter piles and pile group behavior, excavation sequence, and various hydraulic boundary conditions. And also full 3D dynamic analysis, 64-byte multi-core, and free online seminars and trainings. Now let's talk about the second part, about the modeling in MIDAS GTS. So I will do a few demonstrations during this part to show you the software and how it is working. So first of all, let's talk a bit about the interface. So this is the main interface of MIDAS GTS. So in the main window you have the work window. So the work window is where you see your model and you can do your modeling, your meshing, assign the boundary condition and everything. You have a window called the walkthrough on the left, where you can view all the mesh, the geometry parts, the properties and everything which is assigned to your model. Then you have, in this property window below, you have the details about each element which is in the walkthrough. In the output window you will have the results about the analysis. So when you are performing analysis, all the details about how many percent are left will be shown in this output window. You have the task pane on the right. So this task pane is here to help you to perform certain types of analysis. So if you don't know how to assign construction stage analysis, for example, you can click here and it will give you some indication. And you have different types of table window to view the result, context menu. And if you look on the upper part of the screen, you have the main menu and the standard toolbar, the selection toolbar and the working toolbar. So all these toolbar will help you to work with the model, to rotate, to define the snap, the selection option, the type of thing to select. All this will be here. And in the function toolbar, you'll have all the options to do the modeling, do the meshing, assign the loads, the boundary condition. Everything is in this functional toolbar. So you have all the options here in one place. And on the right you have the unit system. So this unit system will it's useful to have it here because you can change this unit whenever you want. So if you want to use millimeter instead of meter, you can change it during the analysis. Okay, now let's go to the next section and talk a bit about the modeling. So what are the options that are provided to you for the modeling? So MIDAS GTS is quite complete for the modeling of the model. You have the curves, the surface, the solid, and every type. You can import different format of geometry, so it can be STEP, IGS, STL, all that, and export. And different type of operation on the geometry. So rather than just explaining you one by one, I will show you the demo in the software, so it will be better. So now I'm going in the interface of MIDAS GTS. So I have it here. I already opened a new project. So first thing I will do is to open a model. Yeah. So the first thing I'll do is to show you how, so this is a 2D surface model that have been used. So I'll show you how to create a 3D model very quickly. So here I created a cube in which I will do my 3D modeling. Second thing I've done is to make it transparent so you can view better what is happening inside. Now I'll reuse the grid face function in order to use the data from a text file in order to create a plane. So I already have the data in the text file, and I just load it to create a plane in the screen like that. And now I will use the operation called trim to cut the model. So now I have my main domain, which is I will use. Next thing will be to extrude the profiles. So I extrude first this one, then I'll extrude the second one, I'll do a basic Boolean operation on that, so I'll do first the common operation. Okay, okay. So you can always preview, so before you do the analysis you click on preview and you will see what it will give. Okay, so I'll do that. Now I'll use the common function to embed, I will embed this into the sol. So again, use the preview, right? And I'll extract okay, so I'll extract this surface here, and I will cut my geometry with this. Preview. Now I'll delete this part. Next thing will be to extract these two tunnels. Right, and to cut the tunnels here. Okay. Now I don't need the curves in the surface, so I will just hide them. I'll delete the part inside here. So I already modeling all the sol and the tunnels. So what I'll do is to prepare the meshing. So I will move the walk plane. Create a face here. And copy it. Preview. Right. Now I will cut my tunnels in order to perform afterwards stage analysis. So I select the tunnels. Okay, so now the model is almost ready, so I can show you the meshing. So it's really easy to mesh all that. I just go on Auto Mesh, Solid, I select all the parts I want to mesh, select the size, click on OK. So here I meshed the interior part, and again I made the full volume. So you see also the meshing is really fast. And now you see I get my model which is ready for analysis. Okay, let's come back to the PPT. So I show you a bit how it works, all these functions, the extrusion, the trim, and everything. So you can create a model very fastly using MIDAS GTS and all the geometrical creation options. Now I'll talk about another feature which is really interesting, and it's one. MIDAS GTS is the only software to have this kind of modeling feature. It's called TGM, or Terrain Geometry Maker, and it will help you to extract the shape of the terrain you are walking on directly from the DXF file without entering all the text value. So I'll show you a demonstration of that because it's quite interesting to see. So first of all, I have to go in the toolbar and to open the Terrain Geometry Maker. Then import my DXF file. If you have some invisible layer that you don't want to consider, you can include them here. Otherwise, here you can select, so you have the map here that I entered. So for the base contour you can select everything. Then you have to select the specific zone you want to study. So here you can zoom to see a bit more precisely what happened, and just select like that plot zone. So it will be, I will extract this zone. And when you click on OK, you have a preview of what you will get in the window on the left. So here I choose 200 points for the sampling, so my surface will be very precisely fitting to the map. So you can have, so now that you've done that, the only thing you have to do is to export it. So I'll give a name. Then you can come back to GTS and import from the Geometry Terrain Maker the surface that I just made. So here you have it here. It looks like it's a surface. So now to generate the solid, you can just use the simple geometry option. So you create like that a surface, extrude it in Z direction, you can preview what it gives, and you only have to trim like I did in the first example. And now you get your 3D model of the surface. So it's really fast, as you see. You don't lose time to search into your data, to put it in a text file and everything. and import all that into the software. So you can have directly your surface modeled inside GTS just in a few clicks. Right. Now let's come back to the PowerPoint and continue the visit. So let's talk briefly about the mesh generation. So MIDAS GTS provides different type of mesh generation, not only automatic but also map meshing, different kind of operation and manipulation on the mesh. You have different type of meshers as well, the loop mesher, the grid mesher, Delaunay mesher, all that can be considered. Now 3D meshing, tetra meshing is quite fast. So you have a fast tetra mesh auto mesher, and it can create smooth transition between the smooth mesh and the areas where the mesh is coarser. I feel there's a bit of delay between the screen and the sound, so sometimes I just make it a bit slower. Okay, so you have map meshing as well. So the people who really want to create good mesh to have more accurate results, they can use this map meshing function. Okay, let's go on. You have some functions to check the mesh quality as well, if you want to check that your mesh is well enhanced. Now let's talk about the boundary and the load conditions. So you have all these kind of load conditions that can apply in GTS. Ground support, the beam end release, the plates. You can even change the element attribute, which is very useful function during the construction stage analysis. So if you have first you have some concrete which is hardening during the analysis, so you can also have such kind of conditions. Now you have all kind of general loads like the self-weight, the moment, the force, pressures, and if you're doing dynamic analysis, you have time history analysis data. You can also create blasting dynamic load, train moving load, all that. So if you are doing seismic analysis, you have a database of seismic data which is directly accessible inside MIDAS GTS. So selecting the kind of data you want, you can modify a few coefficients if you want, and then you'll just have to import this into the time history function to create and apply it on your model. Same for the blasting. So for the blasting, you only have to define a few coefficients relative to the blast. So it can be the velocity, the explosive density, all that. And the function will be auto-generated by GTS. So as GTS can perform dynamic analysis, you can do this blasting on the soil and view the reaction over and all the structures. You have also train moving loads if you want to analyze the train loading. And finally, a few words about the modeling wizards in GTS. So you have a few wizards. So the wizard is here to help you to do a certain kind of analysis, because when you begin to use the software, maybe you don't know how to do that. So using, for example, the construction stage wizard, it will help you to define rightly the stage for the construction. Now you have the tunneling modeling wizard. So by just defining some coefficients for the tunnel, you can define directly the tunnel and also the boundary condition, the construction stage, all that is considered. So for example, this model has been modeled entirely using this tunnel wizard. So it generates the form of the tunnel, the different stage for the analysis, the different things that you need. Yeah, the soil layer, all that is considered. And finally, the anchor modeling wizard. So if you're doing this kind of consolidation analysis, excavation, and you have to define these anchors. Sometimes it's quite painful. So in GTS, you have a module to help you to define that automatically. So it comes with, you can define the material, section, the angle, all that. So just a small summary. So first of all, you have the pre-post analysis, all that in one program. So it's quite convenient, and everything, the windows and toolbars are easy to access. You have MIDAS GTS modeling features, so all the tools, data exchange to do real 3D modeling. You have the TGM that I have shown to you to generate realistic ground surface. You have GTS mesh generation, so auto and map mesh, and also advanced features, and boundary and load conditions. So, and also the modeling wizards to help you. Now, maybe you're wondering, yes, I can model my project and everything, but what can I analyze with MIDAS GTS? Well, I talk a bit more in detail about all the analysis function in this section. So, MIDAS GTS is made around such types of analysis. So all these analysis types can be performed. Static analysis, linear and nonlinear, construction stage analysis, that it can be drained or undrained construction stage analysis, seepage analysis, time history, response spectrum, so for the seismic analysis, equivalent linear analysis for the soil structure interaction, eigenvalue, slope stability, consolidation, and semi-coupled analysis. So you have a few animations on the right showing you the construction stage analysis of different types of models. Let's begin with the construction stage analysis. So MIDAS GTS is very practical to define such kind of construction stage projects, because there you can use construction stage, seepage, slope stability, and for each you can use the construction stage. So you can obtain in situ the ground conditions for the various soil layers. Then you can activate and deactivate the boundary condition, the loads. You can use the wizards to define automatically the stage and simulate and really capture the real construction stage sequence. Now for the slope stability, there are two main methods that can be used. The first one is the stress reduction method, called also SRM. The second one, the stress analysis method, can be used as well, and it is based on the limit equilibrium method. The seepage analysis considered steady state or transient analysis, so you can obtain the flow quantity around the surface of a dam, for example, a tunnel or an excavation site, and you can consider the unsaturated soil as well. What is called semi-coupled analysis is the coupling of the seepage analysis with the consolidation analysis. So usually when you perform the seepage, the pore water pressure which is obtained from the seepage, it is actually modifying the condition of the ground, and it can cause some it can make a decrease of the shear of the tensile strength of the sole. So you need to consider first the seepage and then do the stress analysis to view the correct results. Now, consolidation analysis. So it can be done for 2D or 3D structures. So you have a few examples here for harbor structures or pier structure. You can consider bidirectional drainage boundary condition. And what I call the 1D, 2D ground response analysis is to study the sole structure interaction. So you can determine the critical seismic loads causing the structure failure and the liquefaction of the sole, for example. So you can predict the ground vibration to obtain a design response spectrum. Now the response spectrum analysis, so this is the response to the seismic data. So as I told you, you have the database for that in the software. Then it can be applied easily on the model to view the reaction of the sole and different coefficients, dynamic coefficients like damping can be considered in order to consider the response and view reaction of the sole. Time history analysis, so seismic load for vibration. So you have two main methods to do that, the model superposition and the direct integration method. Now, what is important in geotechnical software is also the material models, because you know that the sole is mainly a nonlinear medium. So you have to consider a lot of different conditions for the sole. So linear elastic is quite simple model, but in GTS you have 15 material models that you can consider. So in function of your sole, if you're studying rocks, clay, or if you have a very specific type of ground, you can even use your own user code subroutine in Fortran in order to make the best sole model for your analysis. You have different type of element library, so you can consider 1D, 2D or 3D elements, and particularly for 1D you have the truss, the embedded truss, the beam element, different types of tension element, tension only element, for example. For 2D elements you have the elements used for the interface. So gauging plates are here to view the force around a solid. You can use plane stress, plane strain elements, or plates to model shotcrete, lining, walls. And you have also special types of elements for more specific applications. Now I go very fast on this solver because it's a multi-frontal solver. It's faster than an iterative solver, and it's also provide you more accuracy and speed for analysis. So all that is directly integrated into GTS and is available in 3264-byte systems. So we have done a few benchmarks of that, and MIDAS GTS is faster than all the solvers in order to when you want to get the results. So in function of the elements you have in your model, it will be even faster than the others. So the analysis capabilities are really wide. So you have static, nonlinear, construction stage, slope stability, seepage, semi-coupled analysis, 1D or 2D ground response, response spectrum, and time history. Then 15 material models to analyze the best soil behavior. You have good solver with 32 or 64 bytes solver, and which is one of the fastest solver for large solid models. And let's talk briefly about the post-processing. So now what you're wondering is that when I calculate everything, how do I extract my results? Because the purpose of this analysis is to get the results you need for your project, of course. So you have different ways to get the results. First of all, on the walkthrough, you can directly select the results by stage. Then you can view the contour plot of the model directly and export these results into tables or Microsoft Excel and get the graphs. I'll show you directly some example of that, so you will see how it is convenient to get the results. So this is a 3D construction stage excavation example. It's already been calculated, of course. I'll show you what the tools you have in order to extract different kinds of results. So if you go on the walkthrough here, you have the different steps of the analysis. So this is construction stage, which has 36 steps. For each step you can view the results, so reaction, displacement, strain, stress, and the ground status. So I'll begin with the displacement. So in specific direction, let's look at the dxyz displacement first. So the first stage, of course, I didn't begin the excavation, so the ground reaction have been set to 0. Then if you go step by step like that, you'll see the excavation process. So one by one I will turn the model like that so you can see a bit better. So one by one you have the excavation like that of the layers of the ground in the tunnel. And this is okay, last step results. So this is the displacement, the total displacement of the ground. Now let's look at the stresses. So different type of stresses can be viewed. You can view the XX center stresses, von Mises, so mean total pressure, the solid pore pressure. So if I check the von Mises center, for example, same, this is, you can be step by step what is happening into your ground. So each stage of the excavation you have the results. Now you have different type of view for these results. So you can view like I've done for band, or you can view gradients if you prefer. You can view the mesh. So these are the mesh edges of my model. I'll show you the last step. Displacement, okay. Now you have some tools for to view the isosurface. So you can view the different isosurface of the model. So if you want to know, for example, in which zone of my model I have a big displacement like that, you can directly check the isosurface. And it's a multi-stage isosurface, so you can add several isosurfaces together as well. Now you have the clipping plane in order to cut a section of your model. So you can, like that, drag and drop this clipping plane, so you know exactly where you want to cut and view better inside. So here I have a view inside of my tunnel. Now you have some to extract the results. First of all, you have some tool called the probe tool. For now, only MIDAS have such a tool. So it helps you to put some small indicators at any node you want of your model, so you can very quickly check at this node what is the displacement, what is the stress. So it's very helpful to check the model. And when you modify the stage, for example, of construction, this is updated, so you know each stage you will get what. Then you have some tools to extract the results. So if you click just on one node, you can extract all the results and export into Excel or draw a curve directly. So okay, I will come back to the PPT. So different types of contour plot. Now you have you can view the deformation or the undeformed model as well. So you have animation as well. So if you're doing construction standard analysis, you can create an animation and export directly this animation into video format. You can view the isosurface, so it's a multiple isosurface to really view what is happening. Multiple slice plane, so you can cut in different slice plane. Multiple clipping plane to see what is happening inside. So this is a small animation also about the construction stage analysis. So you can export this kind of animation after you made analysis to directly view results. Now 3D, you have the on-curve graphs. So you can directly on the model draw the curve of the displacement or the stress to see directly what's happening on the model. And so you can extract data at any node or any element and draw the curve directly. Now you have several types of view. So you have a flying view. So flying view helps you to enter directly into your tunnel to view better what's happening. So you can directly do like if you were inside the tunnel to see where you'll have the displacement and everything during the construction. The probe tool helps you to get the result at any node. Okay, virtual transformation. The hybrid plots. So if you want to see different types of plots at the same time, like the contour or the vector plot, it's possible. The flow path for the C-page analysis. And the extraction of results. So step by step, stage by stage, like that, you can extract the results and draw the graphs directly. And this is the 3D step graph for construction stage analysis. Now, animation. So, for example, the dynamic effects of the high-speed train. Maybe you cannot see the animation on the left, but it's almost the same on the right, but you have a hole in the ground. So to view the influence between the two. So now this is the last part of this presentation about the project application, because MIDAS GTS is a software which is widely used internationally by a lot of big companies, and I'll show you a few projects that have been done using MIDAS GTS. So these are some different kind of tunnel projects. So slope stability analysis as well by stage. Foundation analysis. So it can be foundation or the pier analysis, the driven pile analysis, or any kind of raft foundation. Excavation and temporary structures for the subway station, or if you want to add the diaphragm wall, temporary structures for the foundation of the high-rise buildings, the stress distribution for the subway line, soft soil and embankment analysis, so vertical drainage, consolidation analysis, hydraulic and underground structures. So here you have a seepage analysis for embankment, the fitting of waterway of a tunnel, and underground driveway analysis. And I'll show you a few projects one by one. So one of these big projects using MIDAS GTS is the Dubai Tower in Qatar. So it comprised the construction of approximately 80 floors of high-rise towers with mezzanine, ground floor, and 5 basement levels. And it's the tallest structure in Qatar. It has been founded on piled raft foundation, and in order to understand fully the behavior of the foundation, a 3D finite element model was required. Now the Palazzo Versace, it's also in Dubai. It's located on the west side of Dubai, and it's also a very big model that required 3D finite element analysis for the foundation and the pile raft foundation to understand the correct behavior of these structures. The Abu Dhabi Tower in the UAE, the King Cross Station in the UK. So the section of the existing tunnel where the shaft intersects is the first strengthened with block work, and the cylindrical section of the shaft is built with a segment lining. So then the tapered section of the shaft is built in 1 meter deep stage and lined with sprayed concrete, and after spray the concrete strengthening, the connection is achieved and the block work was removed. So this is this analysis. The Trans-Hudson Express station, so this is a very complex subway station modeling entirely in 3D. So it was to check the settlement in conjunction with the structural analysis, to check the stability of the lining structures for the subway complex. Trans-Hudson Express Avenue, the Helsinki subway western expansion. So it's construction stage analysis for new tunnels and underground structures, and it's also calculate the foundation pressure on the existing structures on the tunnels. So it can be monitored and the structure of the tunnel can be optimized accordingly to this. So it was a very big analysis which was constructed in 3 blocks. A final disposal facility in Onkalo in Finland. So this is a nuclear fuel disposal that used MIDAS GTS. It was to investigate the overall stability of the hard rock excavation in depths up to 500 meters, and also to optimize the rock support system. And what was really important was the impact of the vibration due to the blasting and the groundwater level of the underground cavern that was simulated. Another very big project is this Odeon Tower in Monaco. So the assessment of the ground surface movements, especially in adjacent building foundation, and the check of the global stability was done considering the 3D effect and the static equilibrium of the excavation, and especially considering the arching effect of the uphill side. It was, you know, in Monaco there's a lot of buildings everywhere, and building a very high-rise building like that in middle of all that is very complex. So this project was really complex, and using GTS to perform all that was really a big help for this project. Now the highway construction project. Concrete phase for the dam analysis to evaluate the water pressure. Navi station breakwater analysis to evaluate stability of the ground and the earthquake. And this is an underground structure project. So here the pipe-proof method crossing lower part was evaluated for the ground deformation check with each construction stages. Okay, a summary about that. So MIDAS GTS is really an all-in-one FEA analysis software, especially for geotechnical engineering. It's intuitive and easy to model. It has a lot of capabilities for analysis, and it's fast. Post-processing is really visual and a lot of practical operation to get any type of results you need for your project. So in a summary, it will really increase the productivity of your company in a new dimension. Expand your business areas, you'll have more projects, and MIDAS support team will help you to complete your building project and to train you in order to use it in order to perform correctly and fastly your analysis. Okay, it's the end of today's presentation, and right now we'll have question section. So if you have some questions during this presentation, please just write them into the chat section and we'll answer them right now in direct. Now before leaving, if you can just fill the small survey that you will be proposed to fill, it will help us to improve the next webinars, and it will be really helpful for us, so please just take 1 minute to fill this survey. And of course, I hope I will see you to the event we organize in Romania the 5th of November. I will be there, so you will be able to meet directly. Okay, thanks. Okay, then if there's no question right now, you can still send them by email. I'll write you my email, which is cyprian@midasit.com. So don't hesitate to write me an email if you have some question about the software, about how to use it, or any question you want, and I will answer you. Okay, see you next time for the event in Romania. And have a good day. Yes, bună ziua.